This video is going to walk you through some application problems that you can do with systems. So let's suppose a theater owner wants to divide a 3,600 theater into 3 sections, with tickets costing $40, $70, and $100, depending on the section. He wants to have twice as many $40 tickets as the sum of the other types of tickets. And he wants to earn $192,000 from a full house. Find how many of each type of seat he should have. So let's go ahead and start by defining some variables. I'm going to let F be the number of $40 tickets. I'm going to let S be the number of $70 tickets. And I'm going to let H be the number of $100 tickets. So once we have those variables established, we can think through what our equations are going to be. First of all, we know that there's 3,600 seats in this theater. So the number of $40 tickets plus the number of $70 tickets plus the number of $100 tickets should be 3,600. Since we know how much he wants to earn from a full house, we can put that information together with the cost of the tickets. So that gives us 40F plus 70S plus 100H equals $192,000. The last thing we need to handle is the fact that he wants to have twice as many $40 tickets as the sum of the other types of tickets. That gives us that F should equal 2 times the sum of S plus H. So we can go ahead and let's clean up what we've got and let's come up with some equations and some matrices that can go with this. So you can see that the first thing that I've done is I've solved that bottom equation and gotten 0 on the left-hand side so that all my variables are to the right. Now what I'm going to go ahead and do is put equations 1, 2, and 3 into matrix form. So what I'm going to do next is I am just going to switch row 2 and row 3 so that I've got that 1 sitting in the position where the 40 is currently located. So all that's happened is that switch has taken place. The next thing that I'm going to do is combine row 1 and row 2. So when I do that, row 1 is going to stay put. When I add row 1 and row 2, I'm going to end up with a 0, a 3, a 3, and a 3,600. And I've not done anything to row 3, so we're just going to recopy that one completely down back into row 3. Next, I'm going to go ahead and multiply row 1 by negative 40. And we're going to add that to row 3. And then finally, we're going to multiply row 2 by negative 10 and add it to row 3. And you can see at this point that we really are almost there. 2 things of division that we can do. We can divide row 2, everything in row 2, by 3. And I can divide everything in row 3 by 30. So let's go ahead and do that. Once we do that, you can see that we've gotten everything we want. We've got 1s all in our diagonals here. And we can go ahead now and wrap the problem up. So remember that this was F, this was S, and this represented H, those columns. So I now know that H is 400. So I need 400 $100 seats. I'm going to use that second row there to write my equation S plus H equals 1,200. And since I know that H is 400, that makes S equal to 800. So the $70 seats are 800. Then I'm going to write that top row as S, F plus S plus H equals 3,600. And I know that S is 800, H was 400, so that is going to make F 2,400. So there's 2,400 $40 seats. So the next problem that we're going to look at is about a manufacturing capacity. So we've got Krug Industries. They're borrowing $440,000, part at 6%, part at 8%, and part at 10%. We know the sum of the money borrowed at 6 and 8% was 3 times that was borrowed at 10%. And the loan was repaid in full at the end of 5 years, with the interest paid being $34,400. So what I've already done for you is written out the equations that you need. X, Y, and Z represent the amount that was borrowed at 6, 8, and 10% respectively. So the first equation comes from the fact that we know that they borrowed $440,000. And we know that they borrowed some at 6, some at 8, and some at 10, with the interest being $34,400. That's where the third equation is coming from. And then from this part in here where it says the sum of the money borrowed at 6 and 8% was 3 times that borrowed at 10%, gave us our second equation. So what I've gone ahead and done is I took the second equation and cleaned it up here, as you can see, and got all the variables to the left-hand side. In the third equation, I went through and multiplied everything by 100 so that there weren't any decimals. And what I've done is gone ahead and written that as a matrix. We're going to go ahead and multiply the top row by -6 and add it to row 3. When we go ahead and do that, you're going to notice that we get the 0 in the spot here that we want. The next thing that we're going to go ahead and do is multiply row 1 by -1 and add it to row 2. When we do that, we end up with the matrix that you see here, which is nice because now we can go ahead and swap out the second and the third row. That's going to now give us almost exactly what we need. 0, 2, 4, 800,000, 0, 0, -4, -440,000. So if we divide row 3 by -4, and if we divide row 2 by 2, we're going to end up with the ones that we want. So then we'll have 1, 1, 1, 440,000. We'll have 0, 1, 2, and then we're going to have 400,000. And then we're going to have 0, 0, 1, followed by 110,000. So now we know that Z is equal to 110,000. So now we know the amount that was borrowed at 10%. So we'll just use the other equations. We knew that y plus 2z is equal to 400,000. And now that we know that z is 110,000, we can plug that in and go ahead and solve the rest of the way for y, and we'll get 180,000. And we'll put those two values back into the top row here, and you should end up, when you solve that, with x equals 150,000, which is the amount at 6%. So to wrap up, I want to just tell you not to get frustrated. Application problems are hard. So you can use your calculators if you want to use them if we're doing matrices. You can use a matrix, you can use elimination. I'm not going to be very particular as to which method that you use, as long as you can set up an equation, the three equations, and solve for the unknown given an application problem. So I want you to take your time, do your homework problems, and we will meet and discuss if there's any questions.